Hello, everybody. Welcome to today's challenge. Today we have a radical equation with cube roots and square roots together. The first one is no calculator. In other words, without a calculator, simplify the cube root. Under it, we have 7 plus the square root of 50 plus the cube root. Under it, we have 7 minus square root of 50. So how do we solve this without the use of the calculator? Let's take our solution here. Okay. Here I'm going to show you the step-by-step way or guide to solving radicals of this kind. So here we want to do a major substitution and a minor substitution in here. So the first one, we're going to bring something to represent the whole of this equation, or sorry, this expression, because this is not an equation. So here we're going to say here, let's take our simple alphabet F be equal to the whole of the expression, which is the cube root of 7 plus the square root of 50. Inside it, there plus the cube root of our 7 minus the square root of 50. And if you look at these two expressions, you discover that this is a conjugate of this very guy here. Okay, now again, we're going to bring some other alphabet to represent this and this separately. So here we want to use M. So here we'll say let M be the first one, which is the cube root of our 7 plus the square root of 50. Okay, then and our N, let our N be the second one, which is here the cube root of 7 minus the square root of 50. Okay, so from here, we want to eradicate or eliminate this cube root here and this cube root here. So what we do, we take the cube of both sides of the equation. Okay, so if we cube both sides, look at this here now. So this is going to give us, let's take from here, this means our x to the power of 3 is equal to the cube root of our 7 plus the square root of 50, right? Then plus the square root of, sorry, cube root of 7 minus the square root of 50. Okay, everything here all to the power of 3. All right, now if you take a look at the side of this expression here, we can draw up an algebraic identity that will enable us to solve this, whereby we're going to take the whole of this to be A and we take the whole of this to be B. Okay, so from here we have our algebraic identity. It says that if you have your A plus B all to the power of 3, this is equal to our A to the power of 3 plus our B to the power of 3 plus our 3AB bracket A plus B close bracket. You remember this? Good. So if we take this, and again we said the whole of this is A, the whole of this rather is A, and the whole of this is B. So this expression we have here now is in this format. We want to express it in this format. So this is going to give us here our x to the power of 3 will now be equal to, if we find the cube root of this expression here, this cube will go with this cube root. Remember? So here we are left with this. So we're going to have this to be our 7 plus the square root of 50. Okay? Then plus our B. This will go with this, which is this. We cancel out this. So we are left with it plus our 7 there minus the square root of 50. I believe there's no problem here. Then we have here plus the 3 is our constant term, A times B. So we said the whole of this is our A and the whole of this is our B. So this is going to give us bracket. The first one is this, which is the cube root, okay, the cube root of our 7 plus the square root of 50 close bracket, the bracket, the cube root, this cube root please, of our 7 minus the square root of 50, right, the close bracket. Now our A plus B, let's get it from our equation here. Look at here, we said the whole of this is our A and the whole of this is our B, which is what I did here now. Okay, so this plus this is equals to our X. So we can put in our X here. So everything times X here. Okay, so here is X. times this. All right. Now, if you look at this, we can do some simple calculations. This and this will leave. So we're going to have our x to the power of 3 is equal to 7 plus 7 will give us 14. Then plus our 3. Look at this. Here we are having a cube root. Here we are having a cube root. So we can multiply what we have in here together. So doing that, this will give us bracket the cube root of our 7 plus the square root of 50, close bracket, bracket open, 7 minus square root of 50, close bracket, right? Everything, let's put our square bracket here, everything into our x. From here, we see that this is a conjugate to this. So we can factor out this out. So this is going to give us here our 14 there plus our 3, okay, into the cube root of this times this will give us 49 there minus, because they are conjugate, there this times this will give us our 50, right? So we're going to give us 50. The square root of 50 times the square root of 50 will give us 50. Okay, then close bracket into our x. So we can subtract this from this easy, and this will give us minus 1. So we're going to have this to be our 14 plus our 3 into 3, sorry, the cube root of minus 1 here, close bracket into our x here. Okay, we are almost there. So what is the cube root of minus 1? Cube root of minus 1 will give us minus 1. So this will now give us here our 14 there plus our 3 into minus 1 into our x. So if we open up everything here, this will give us minus 3x. So this is going to give us here our 14 minus 3x. Again, remember we have our 3 to the power of x here. Sorry, x to the power of 3. We have it on this other side. So we want to move everything to this side of the equation. This will give us here x to the power of 3 minus or plus our 3x minus 14 equal to 0. So what kind of equation is this? This is a polynomial equation of third degree order. So how do we solve for the three roots that we actually satisfy this polynomial equation? We use the trial by error method to get the first root to this. So using the trial by error method, we discovered that plus 2 will give us an answer, or it give us the 0 to this expression here. So this means that our x minus 2 is a factor. Put this in bracket. Factor. So if x minus 2 is a factor of this polynomial equation, we want to use the long division method to get the quadratic equation that will multiply together with this to give us our original equation. We have here our dividend x to the power of 3 plus 3x minus 14, right? Here we have our x minus 2. So we use this s to divide this s to the power of 3. This will give us x to the power of 2. So let's put here x to the power of 2. Let's use it to multiply everything here. So this time this will give us x to the power of 3. Then x to the power of 2 times minus 2 will give us minus 2x to the power of 2. Okay, so we rule of this. Then we now have attach our minus to this, so we subtract, right? So in subtracting, plus s to the power of 3 minus s to the power of 3, this will give us 0. So minus times minus will give us plus. So s to the power of 2 under this equation is 0. So we're going to have here 0 plus 2 x to the power of 2. This will give us plus 2x to the power of 2. We bring the next term down, which is our plus 3x. Again, we now use this to divide this. So x divide 2x to the power of 2. This will give us plus our 2x here. So let's use this to open this to multiply everything here. This will give us here 2x to the power of 2. Then this time this will give us minus our 4x here. we roll up again and we subtract. Then we have plus 2x to the power of 2 minus 2x to the power of 2. This and this will leave again. The minus we times this minus to give us plus. So we are having 3x plus 4x. This will give us 7x here. Then we bring the last 10 here, which is minus 14. We use this to divide this again. We are left with our plus 7. So we have here plus our 7, right? Then we use this to times this will give us plus 7x. And this time this will give us minus 14. So we do our number subtraction again. So this will leave. So this time this will give us plus. So minus 14 plus 14, here we have 0, 0. So at the point where we have 0, 0, so we now have our equation to be our x minus 2 plus bracket, our x to the power of 2 plus 2x plus 7, everything equal to 0. So we have two cases from here now. So we're going to solve case 1 and case 2. So we have our case 1. Case 1, we have our x 2 equal to 0. So we have x is equal to positive 2. This is our x1, the first value of x. Okay, good. Now we want to look for case 2. We have our case 2. Case 2, we have our x to the power of 2 plus 2x to the power of 7 equal to 0. This is a quadratic equation. And in solving this quadratic equation, I want to use the formula method to solve this. So using the formula method, it says that our x will now be equal to minus b plus minus the square root of our b squared minus 4ac all over 2a. Right? So what is our a? We know from here our a is equal to the coefficient of x squared, which is 1, and our b is the coefficient of f, which is plus 2, and our constant term c is equal to 7. So we want to put these values into this. Here we're going to have our x will now be equal to minus 2 plus minus the square root of 2 to the power of 2 minus 4 into 1 into 7. The bracket everything all over 2 into 1. Okay, so here we're going to have this to be minus 2, plus minus square root. Here 2 to the power of 2 will give us 4, then minus 4 times 1 times 7 will give us 28. We have 28 here, this is minus 28 all over our 2. So we can subtract this from this to give us our minus 24, right? So we're going to have this to be equal to minus 2 plus minus the square root of 24 minus 24. Okay, everything all over 2. Now we can rewrite this very one by giving us here minus 2 plus minus the square root of minus 1 times. Now 24 can be written as 4 times 6. So into 24 is 4, square root of 4 times square root of 6. Okay, everything all over 2. Now here we have the square root of minus 1. We know that the square root of minus 1 is equals to I. So we can bring in I here, here 2, and all that. So therefore, this is going to give us here our minus 2 plus minus 2 into square root of 6i. Okay, let's put the I here. So we have here 2i. Okay, everything all over 2. From here, we can factor out 2 from this system here. So this is going to give us here our 2 into here we're going to give us minus 1 here plus minus our I into the square root of 6 close bracket all over 2. Of course, these two go with these two. So we'll end up having our x will now be minus 1 plus minus I into the square root of 6. So we have our x 2 is equal to minus 1 plus I to the square root of 6. The x3 is equal to minus 1 minus I to the square root of 6. Remember, we solve for our x1 already. Our x1 we solve for is just 2. So these are the possible answer we can have from the simplification of the original radical equation, which is this here. So if you simplify this, you're going to either have x1, which is 2, or x2, which is minus 1 plus I root 6, or x3, which is equal to minus 1 minus I root 6. Okay, although rhetorical, but we finally gotten the solution to this tough challenge. So if you love something from this video tutorial, give the video a thumbs up. And if you're new here, you've not subscribed, subscribe to our channel because here we bring math solutions that are well detailed on your way every day. Thanks for watching our math solutions. Keep watching Math Prowess, even as we bring more solutions from rhetorical, from tough mathematics to you. Bye for now.